Okay. We're talking to Robert Aish, who is an expert in computational design. Robert, you've just come to Autodesk. Tell us a little bit about your background and what you're doing at Autodesk.
Right. Well, I've been in this area of computational design for about 15 years now. I worked at Bentley before I joined Autodesk, and we developed there the generative components application. And so now I've moved across to Autodesk, and we're going to do even better things than we did before. And it's starting off with this design computation symposium that we're organizing at AU. We've got about, I think, 8 speakers who are really telling us what existing design computation work has already been done on Autodesk applications. For example, we just heard Neil Katz from SOM talk about his work on the World Trade Center, where he wrote special programs so that he could explore different options in the configuration of that building.
So this is something new now at Autodesk. Can you talk about what this means in terms of design innovation?
Right. Well, traditionally, designers have got out their felt tip pen or their 4B pencil or their repeater graph, and they drew paper. And then we developed computer applications that really emulated those drafting techniques only on a computer screen, and that gave a lot of advantage because you could edit the drawing and you could tidy things up and you could change things. You could edit things in a sort of normal way, rather akin to word processing. You know, if you made a mistake or there was a spelling mistake or something, you could correct that and print out a pristine document. But it didn't really change the way we write, and drafting tools don't really change the way we draw. It's still a very manually intensive process. But a lot of buildings are essentially the application of rules. I want to populate this facade with this kind of glazing panel or these kinds of mullions. And I want to change variations. What would happen if I had a different proportion glazing panel, for example? I wanted to put a sunshade on those panels that responded to where the sun position was. It would get very, very repetitive and tedious if I have to manually redraw that facade as I want to explore different options. So our existing use of computers has a tremendous manual component in it. You know, we are with direct manipulation and computer graphics, which of course facilitates that manipulation. It's a lot of hard work. Now, if those rules could be expressed in an algorithm, and I just had a slider that I could, you know, play with to say, oh, change the overhang of my shading device, or change the proportion of my glazing module, then I could explore different options much more easily. But to do that, I have to think more profoundly about, well, what are the rules? We can't tell you what the rules are. We are the writer of the software. We're the designer of the tools. We have to put into the hands of the user the ability to specify those rules for himself, for his own building, to make his architectural practice unique.
So that germ of innovation has to be there, and then the algorithm helps you make it happen.
Yes, you have to. I mean, there are obviously standard algorithms, but if, for example, if you want to win an architectural competition, then your building's got to be incredibly original, and part of the originality can be in defining the rules that you apply to your building. For example, if you want a very curvy roof to a sports stadium, and you want to cover that roof with panels, for example, then it would be very difficult to draw each panel in turn and then change the curvature of the roof. But if you made it algorithmically, then you could play with those options. But of course, we can't tell you what those options are. We want to give you the tools so that you can write your own algorithms.
Well, this is fascinating stuff. Now, where can people, Autodesk customers, Autodesk employees, find out more about this, Robert?
Well, this event, the Design Computation Symposium, is the first event in the Design Computation Initiative that we're starting here at Autodesk. So it's come, you know, talk to me. We hope to have another symposium next year. We've got 120 people registered for this symposium. This is just on spec. You know, what would happen if we did this? Would people beat a path to our door? And they certainly have. And of course, we're writing software, new software, which will encapsulate these ideas in a way that we can propagate out to the wider user base.
Very exciting. Well, thank you for sharing your insights with us, Robert.
Thank you very much. Thank you.